Hello, today I'm going to go over radioactive decay particles identification. So during radioactive decay, this is a good example, this parent nucleus is very unstable. So the only way to stabilize it is to get rid of extra energy. It's got too much energy. And it's going to go through radioactive decay, which will give off or release some of that energy. Now, this can happen in many different ways. The one they're showing here is it's going to emit an alpha particle and release a little bit of energy with that. And now it is more stable. This new form is more stable. That is radioactive decay, okay? Now, for the symbols here, we need to learn how to read them. So this first one is actually my alpha particle, which is a helium atom. All right, so how many protons do I have? Well, the bottom number will tell us the number of protons, so 2. How many electrons? Well, there's going to be 2 electrons that are going to kind of oppose the charge of the 2 protons, 2. Positrons, 0. We'll get to positrons in a moment. And then the mass is the top number, so 4. But this is going to get weirder. So let's see what, and this is an alpha particle. Now, there's other things that can be emitted from radioactive decay. This, that B, is indicating a beta particle. Now, specifically, this is an electron. And you'll see that there's no mass. So for protons, I look down at this bottom number, but that's a -1. That doesn't make sense for protons. And if there were any protons, the mass would have to be at least 1 or greater, because a proton is 1 mass. So protons, there's none. Electrons, that's what we're seeing down here is the -1. That's indicating a single electron. If it was like a -2, there'd be 2 electrons. So that one just has a -1 electron. Positron, none. That's going to be next. We'll talk about that. And then I look up for the mass. Again, it's 0 up here at the top, so that is my mass of 0. The electron does not have a mass, or it doesn't have a relevant mass. All right, let's look at this next one. This one looks just like what we had, but instead of a -1, it's a +1. Well, this is a positron. Positron is the opposite particle of an electron. So positron, instead of being negatively charged, is positively charged. Protons, well, it's still 0 because I have no mass here. Electrons, there's no electrons because otherwise it would be a negative, right? So 0. Positrons, well, there's my +1, so I have a +1. I have 1 positron. And then my mass is still 0. So again, it's trying to read how we have this set up, because there's a couple of other things that we aren't including in this particular list, but the setup is what's going to help you with future problems. All right, now this symbol here is for a gamma ray. And you notice there's no numbers, right? And that's because a gamma ray is simply a wavelength of high energy. It's a high energy wave. Since that's a high energy wave, it does not have any particles associated with it. So protons, 0, electrons, 0, positrons, 0. And do we see any mass? No, we do not. 0 across the board. This is just high energy that's being released during radioactivity. So do the same thing for each of the other examples that we have here. I believe we've covered all the examples that are going to be on this worksheet. All right, let me know if you have any questions. Thanks.